Hello, everyone, and welcome to the Impractical Machinist podcast. My name is Patrick. You can find me on Instagram as @JobShopperTN.
And I'm Cameron from Machining is Cool. We'd appreciate it if you'd give us a 5-star review and like and subscribe to the podcast, wherever it is you're watching.
I'm Bradley with Marvel Machining. Also, if you're on YouTube, be sure to give us a like and subscribe to the Practical Machinist YouTube channel.
On this episode, after many mentions on the podcast, Jarrett Morgan, owner of Possum Solutions, is joining us. He's going to share his story of going from being a film camera operator to opening his own machine shop to make camera accessories. We'll also dig into how automation can integrate into a one-man shop and some information on his own robot setup. Jarrett, how you doing, buddy?
Hey, I'm doing well. Thanks for having me. I'm, been long-time listener, first-time caller sort of situation. But, I love that there are more people talking about stuff. I've listened to all the episodes, and as someone who was very self-taught in this, having people talk about all the stuff is so useful to learn. I've learned so much from the guests and from y'all just talking about your problems and stuff. We all, it's great.
I don't have any problems. What problems are you running with?
Well,
Yeah, Brad's got it all figured out.
Except for probes.
Yeah.
Well, I'm glad that we were finally able to get you on. I think we've mentioned you in a ton of podcasts already.
We've had people commenting who's this possum guy? Can you elaborate on the possum?
Yeah. So a little bit of backstory. There's more in Dylan was nice enough to ask me to be on the With Intolerance podcast. I think maybe a year ago or something. And so if you want really deep backstory, there's more there. But my day job is in the film industry. I'm a camera operator and do Steadicam specifically. And I did a TV show miniseries called The Underground Railroad that Barry Jenkins directed. And about a week and a half into the show, he gave me the nickname Da Possum, because I was so good at digging out the shot and finding the story and the scene and all this sort of stuff. And he was like, like an animal digs around, like a possum, and then it just stuck. And it's it's the thing of if someone who's won an Oscar gives you a nickname, it's hard to get out of it. So you okay, that's who I am now. And I'm almost positive on that movie there were people who came on after that did not know my real name. That only called me that, and it didn't stick past that show, kind of thankfully. I don't mind the nickname, but at the same time it's it's a little possums are great. I'm a big fan now, especially, but it's not the most, it's not getting called the tiger or something,
Right.
It's a little bit of a joke animal at times.
Is there any films that any of us would have watched?
Probably. I did all 4 seasons of Atlanta. The TV show was on FX. I worked on Pitch Perfect 3. I'm sure y'all are big Pitch Perfect fans.
I actually do like Pitch Perfect.
It's a good movie. It's a great movie. Yeah, that's why I did the third one of that. I did second unit on Shaft, the new Shaft movie. I did a couple days on Jumanji 2. I've done a bunch of movies, day playing and working on and making parts for big movies, and I don't know. It's a good. I've been very lucky. The film industry has treated me very well, and I have really enjoyed sort of the life that it has given me. Both been able to travel for work quite a bit, to go to interesting places, to meet interesting people, and the sort of the variety that it does. If I'm on set, we're shooting someplace different every day. We're kind of doing the same thing. It's always making movies, but it's at the same time going to a different location, solving new problems. It's interesting. It's telling good stories, working with good people. There's very little to complain about other than the hours and night shoots.
Are you independent, or how do they find you?
Yeah, so I'm in a union. I'm in IATSE, which is the International Theatrical and Stage Employees Union. But the union doesn't really get us jobs. It's more of a collective bargaining, and insurance and pension go through the union.
Yeah.
So the jobs are all sort of word of mouth. Who likes you? So I can trace every job I get back through the line of well, I got this job because I worked with this person on this job, and that one I got because I worked with this person on this job. And you never know, going out and working 1 or 2 days on a show then leads to this other job because you impress them on that job, and then it just snowballs, which I think is true of most industries.
Yeah.
Like I feel like if you're looking for new employees, you go to your current employees and ask, "Hey, who's good?"
Right.
Who'd you work the last? Like, this is the thing that I think Jay Pearson talks about all the time on like his stuff, where it's like he'll go and be like, who was the favorite person you ever worked with? Okay, let's go hire that person.
Yeah.
And that same thing happens in the film industry. And so
That's why your reputation has to precede you.
exactly.
Yep. People like people who do a good job.
It's true. And also, like, beyond that is like, are you nice to, like, we're going to spend 70 hours a week together. Are you a nice person? Like, do I want to spend 70 hours a week with you? Because I'm sure that happens with y'all, with employees. I mean, Brad's by himself, obviously, but like, if you're working with someone that you do not like spending time with, it makes the job so much less pleasant.
Yeah.
True.
Yeah. That's true. I would honestly rather take somebody who doesn't do quite as good of a job over somebody who does a great job, but I can't stand.
Absolutely. So that's the backstory. That's where Possum came from. So when I started the company, someone suggested that I name it that, and I said, okay, great. And then once you have a name, you kind of stick with it because now everyone knows you as that, and then it snowballs, and here we are.
Possum forever.
Yeah, Possum forever. And it's the thing of like, like you have the aunt who's really into lighthouses, and then you ask her why she's into lighthouses, and she said she mentioned it casually one time, and then every Christmas someone got her a lighthouse.
Yeah.
And now she has 40 lighthouses in her house.
Yeah.
That's just me with possums now, because people will give me bumper stickers and stuffed animals and posters, and like I have a lot of possum stuff now.
We're gonna post your address, and everybody's gonna send you possum holiday.
Please don't dox me.
I know you're basically a camera operator, Jarrett, but can you kind of describe, you're a Steadicam operator, right?
So Steadicam is sort of like a subset of what I do. It's camera operator first, and then Steadicam. So I'll operate the camera like whatever mode it is, handheld, Steadicam, on a crane, whatever it is. But Steadicam specifically, if you imagine a shot sort of tracking behind people or moving through crowds, sort of some of the famous ones are like the Goodfellas shot that goes down through the into the kitchen and through the mafia hideout place and lands on them at the table. Like, that's a Steadicam shot. That's a very famous one that Larry McConkey did, who's like one of like the greatest of all time Steadicam operators. So it basically is like it's a really interesting mechanical device that I think machinists quite enjoy, because there's some very precise parts on it. If you imagine and I think we'll just post some videos or something that can go over while I'm talking about this, but basically it's a slightly bottom heavy pendulum that the camera's on top of, and you have counterweights on the bottom, that's then attached to a spring parallelogram arm via a 3-axis gimbal. And those 3 axes, pan, tilt, roll, are all intersect at the same point. So that spring arm is able to isolate your body movement from the sled, and the fact that it's slightly bottom heavy means that the inertia of the sled wants to stay in the direction that it's going. So basically the idea of it is you're trying to direct that inertia into making the shot as smooth as possible. There's some really interesting like electronic gizmos we have now that sort of like aid you in this. But it's this really lovely intersection of athletic ability and sort of physics and mechanical aptitude, and all these things were sort of mixed together into this like sort of thing that I really, really love and enjoy. On top of that, the freedom that it gives me to sort of move the camera how I want to in a scene without having to communicate as much. A lot of my job on set is communication. If we're doing a dolly move or a crane move, it might be as much as me communicating what the shot is and what we're doing to like 4 or 5 people. And so you can imagine if you're trying to do a very specific thing that's in your brain, or that I'm interpreting from someone like a director who has communicated to me what the shot is, then I'm having to communicate to 4 other people. It can both, there can be errors in that communication, right? That end up making the thing not exactly what's in my brain. But if a Steadicam, it's just me, and I can just do it, and I can do it how I want it. So there are benefits and detriments to it. It's quite heavy. And so it can be taxing to do it all day. And also it is, with the vest and the arm and the camera, it's about 80 pounds.
And that's strapped to you?
It's strapped to you, yeah. So I sort of, I compare it to basically, it's like you're doing ballet with an extra 80 pounds strapped to you, because you're having to be very precise and very, sort of thing. But super fun. I enjoy it. If anyone gets a chance to try one on, I highly recommend it, because it is also a fun, weird feeling. It's a cool thing. It's I don't know. It's like, it's the thing that started everything else in my life. Really was figuring out this is what I wanted to do, and then um, the machining thing is honestly just a hobby that's gotten haywire. It's like gone out of control. So I'm I'm here as someone who has no idea what they're doing and is just like kind of messing around and having fun and figuring it out as I go.
And how did you get into this hobby?
Um, as with a lot of people, two answers. As with a lot of people, I grew up being very mechanically inclined, lots of Legos, lots of taking things apart and trying to put them back together. My mom tells a story of when I was like 5, taking the hinges out of the door because I was trying to figure out how the door worked and like like I was trying to figure out how to take the top one off, wasn't tall enough, and I almost like dropped the door on myself, you know. And then the second answer is basically is this old Tony, like the YouTube channel, like watching and being like, that's cool. I can make stuff out of metal. Dang, like, I don't have to use, like, 2x4s and a jigsaw, and so, during the pandemic, 2020, obviously, we weren't making movies because movies have a lot of people all crammed in the same space, and when one person gets sick, everyone gets sick on movies. Like, it's not like an office environment. We cram 20 people in a bathroom regularly, you know, to make these things, and so everybody just gets sick. So we stopped doing that for, like, 6 months, and I had tons of time, and I was watching this old Tony and went, "I'm just gonna buy a little manual lathe and, like, mess around with this and see it." And I broke a lot of end mills and learned a bunch of stuff, and I thought I could design stuff to be 3D printed and then just machine it, and it turns out you can't. Uh, and then after a while, I went, "That CNC thing's pretty cool. I should do that," and converted my benchtop mill, from manual to CNC, which was a process that took a lot of time and ended up with a machine that was like okay, like, you know, not great, but okay.
Mhm.
But I'm glad I did it because now I know how CNC machines work. Like in a conceptual level, like I can take apart a CNC machine and put it back together because I have. And like everything's bigger. The ball screws are bigger. The motors are bigger. The boards are more expensive. But like it's the same stuff. Like nothing. Like they're not like the machines that I'm working on are not complex when you compare it to like obviously I'm not doing that to a Kern or a Hermle or something, but like the Haas and the Sharp that I have are not complex machines, right? So that sort of basis of building my own or converting my own machine gave me sort of the confidence to say, yeah, I can fix this and then figure it out.
Yeah,
That's
real,
interesting.
really good base experience to have.
Yeah.
I mean, there's a lot of machinists that probably don't have a foundation in the actual mechanics of the machine, at least with a CNC machine.
Totally. And at the same time, I don't have the basics in being a machinist. So, you know,
Right.
it's a trade-off.
I'd say you're doing all right.
I'm doing okay, but I'm definitely like there's been some aha moments, right? Like there's Ben at Speed Machine who is an incredible machinist. At one point we were chatting and he's been a bit of a mentor to me in a lot of stuff. And he asked me if I was trying to dial in some sort of fit. And he was like, "Are you using wear comp?" And I went, "Well, I've seen that, but I just never tried to use it before." And he was like, You should use that." And I went, "Okay." And I went, oh, this is better.
Right.
This
How
is
were
better
you
than
doing it?
it was stock to leave and reposting every time.
Oh,
Yeah, which works. Like
It
it
does.
does. Like I got there, but like,
I think,
wow.
honestly, I think you would be surprised how much of that stuff even regular machine shops don't do.
Sure.
Oh yeah.
I've seen it at machine shops before. They're doing the same thing you're doing, and that's
Right.
their only job as a machine shop. So
I
it's one of
mean-
those things where everybody's kind of on an island, and so
Absolutely.
if you don't know something, you just don't know that you don't know it. And so
Which
you
is
find-
why stuff like this
everybody-
is so important.
exactly everybody just
Yeah.
finds a way to make it work, and then they're like, well, it works. I'm never changing it again,
Absolutely.
which is pretty common in machine shops. It seems
I mean, I think it's beyond machine shops. It's common in everything.
Yeah.
It's
Right.
true. I mean,
You get stuff in the
get that
way.
perspective of like working in the film industry as well. It happens in the film industry that people like, oh, I used this camera on the last show, so I'm just gonna use this camera the next show because it's the one I know and the one that I use and the one I like, and that's fine until all of a sudden it's 10 years later and you're like, I don't know if I want this new technology or I don't know, I tried this other thing, and then someone shows you're like, oh shit,
Way better.
oh
Yeah.
this is better, this is easier, this is faster, this is whatever it is, you know. It's true in all our lives, you know. Do you use that same pan to make breakfast every morning? I bet you do,
Mm-hmm.
right? Like
Yep.
you're not researching what the better pan that will be, you know, faster to clean and give you less, you know, forever chemicals in your brain, right? Like that's not like we use the same pan we used for the last 10 years because it's the one that's there.
No, I would say that you would probably probably be surprised how much you would outperform machinists at a lot of shops you went to.
Oh yeah.
Maybe.
It wouldn't and
Yeah.
it wouldn't take you very long of being there to really have everything nailed down.
And
Yeah.
then it's impressive that you were interested in it and you didn't go somewhere to have someone show you how to run it. You just bought the equipment yourself and then you just went into it.
So part of that was the COVID of it all.
Yep.
Right? Like people weren't like in winter 2020 when Omicron was hitting, I think it was when Omicron was hitting, like people weren't like, hey, come into my shop and hang out with me for a
Right.
couple days. Like that wasn't a thing, right? So there was a little bit of that going on. And I think a little bit of it at the time, it was a complete hobby. I was making zero money on it. I was spending quite a bit of money on it. Turns out machining, if you're not making money with it, is a very expensive hobby.
Even if you are making
Even if you are making money, it's still an expensive
Oh,
hobby. So you know, it is that thing of like, yeah, I part of the learning was the fun, and that's for me with everything I learned how to do. Part of the enjoyment of it is the figuring out the problem. And so had I just gone and someone just sold me a brand new Haas and come and done a training session with me, like it probably still would have been fun, but it's not the same as like I actually really genuinely enjoy working on my machines.
Yeah.
Like I enjoy editing post processors for people. I enjoy like it is the problem solving and the working on it is part of the fun, right?
It seems like that's a common thing with machinists at machine shops. You editing post processors, for example. I enjoy it. I enjoy figuring that out. You know, like Jarrett, I'm like,
Yep.
I want to get into the weeds and really figure out how this thing works and understand what all I can do with it. Come up with ideas like, oh, I could add this to the post processor and it could do this thing for me, or have this information right there where I want it, all this stuff. But I got a lot of parts to make and not a lot of time to mess with post processors.
Right.
So when I do start getting into something like that, it's like you just feel like the pressure of the clock ticking the whole time.
Yep.
Like, all right, clock's ticking. I need to hurry up and figure this out right now. Get it done. That way I can get back to making parts because I'm already behind on everything. And
Absolutely.
it ruins the fun of it, and it's not fun anymore. And it's like all I want to do is make parts faster, so that way I can have more time to do this stuff. But the problem is you start making parts faster, and there's always just more parts to make, and you like still never mess with the fun stuff. So
It never stops.
That's the one thing that is nice about working on like about half the shows, half the movies and TV shows I do are away shows. So I just did a movie in New Orleans for 8 weeks, right? And when I'm there, I can't be in the shop. Like I'm not physically here. And that's the moment where I can be like, yeah, let me mess with this post processor. Let me do this thing because like I'm just sitting here on a weekend or I'm sitting at the airport waiting to go someplace. It's like there's nothing else for me to do.
Yeah.
And that's when it's the most enjoyable. You're right. It's not fun when I'm like sitting here being like, oh, I really need to get this part out. So this guy, like, but I'm sitting here messing with something. The flip side of that is every time I've done something like that, that has genuinely been like, this has been annoying me, or I'm hand editing something, or whatever it is. I have never regretted spending the time. Like I've
Right.
never
Oh, yeah.
regretted making an improvement that cost me a little bit of time because at the end of the day, it always either frees up my brain space, frees up time in the long run, whatever it is. Like I've never regretted making an improvement.
I won't hand edit anything. I
Yes.
can't stand doing that. I mean, it's probably about once a year now I'll come across something that my post doesn't have or just something new. And usually it's something I'm never going to do again, but I have to hand edit it. So then I pull out that NC code and I send it off and say, hey, fix this. And then I'll never use it again.
But it's there.
to Cam's point, like I'd probably sit here and then all of a sudden 2 hours later, I'm like, shit, I didn't run my parts. I just fucked with my post processor for 2 hours for
It's
something
easy
you're
to
never going to do again.
Oh,
So
yeah.
so once I finally went on my own, it was, all right, you guys handle this for me. I don't have time for it.
Right.
Yeah.
The
I'd
one
like to get back into it, but
the one caveat I will say for all this stuff that it's like really fun to mess with your post processor. It's fun to mess with your machine and the parameters and like learn all this stuff and everything like that. You can really fuck it up.
yeah.
Yeah.
Like if you, it's one of those things. If you don't know what you're doing, be like really cautious because like you know I added a probe to both machines. I added a 4th axis to my Sharp. Like I had to go really deep into the FANUC parameters and the ladder and like figuring out because it didn't want to talk, and so I had to go and change settings and things. And I was in there and I was like, I could flip some switches and this machine would never work again.
I
Like if
always
I
do
didn't
pictures
like
before I change settings.
yeah. So make backups. Don't edit the post you're currently using. Right. Know that you're editing this one thing on the post and then output it and make sure it's outputting what you want and save it before you go to the next. Like, don't make 10 changes and then output it and just run the code. Like, be careful, be specific. Like, you can really mess things up really fast when you start learning things because that's like learning's making mistakes, but you want the mistakes to be catchable, not crashable. If that makes sense.
A little tip for editing post processors too. I always put like in parentheses my initials and the date. So that way when I do edit things And I'm like, wait a second, something's not working like it was working before. I can just control F my initials and then go back and find it. Be like, nope, that was 3 years ago. That's not it. Yeah.
Yep.
Can
Comment
you?
your code. That's true of like coding in anything. Is like you
Yeah.
want to have very clear comments. This is doing this for this purpose, and
Yeah,
I made this edit this time. Period. Like,
Put a description there.
yes, absolutely.
Can you suppress certain stuff in your posts, or I mean, almost like a block delete? I don't know. It's
Yeah.
been years since I've done it.
Comment it out.
I've talked to a couple post builders with my software, and they have, their basic library posts. It has settings for every type of machine. So it doesn't matter if you have a Haas or a Makino. It's just a suppress section they can unsuppress. So then when they're editing, they can edit below and suppress. Can you do that too?
Yeah, you can just comment it out. Like you just literally put a backslash in front of the line, and it just ignores it.
So like block delete. Yep.
Yeah, exactly. Yeah, exactly.
That's cool. That'd be helpful. I mean, I didn't know that 10 years ago. I don't know if it's something new, but
Well, I
that would've been
also
helpful, 'cause I got caught in some situations where I change stuff and hit save and then I go post it and it's like, oh shit, what did I do?
Yeah.
I got to try to fix this.
When you said that block delete thing, that reminded me. I've been meaning to mention this because it may be a helpful tip for some people out there. So whenever I'm programming stuff, also like you're talking about dialing stuff in using cutter comp and all that. Like say you've got a fit to dial in on a part, I will make all of the toolpath optional. So on Fusion, you can highlight it all, right click, select optional, and it'll add that optional block skip to all the toolpath or all the lines of code for that specific toolpath. And then I will leave it off only on the stuff that I need to dial in. So I'll offset all my, like on the mill, I'll offset all my tools at 1,000th, run the entire program, configure it all, turn on optional block skip, make my offset adjustments on my wear, and then run it again, and it'll just run the important stuff.
That is brilliant.
Yeah, super handy.
Very handy.
You're not skipping down through, and like say you've got a tool that's finishing floors and walls and not non-critical features and stuff. You don't have to let it run that whole, all the non-critical stuff over again. It'll just come in, run the stuff you need, and then you're done. And you don't have to go find it. You just block, skip, go.
Right.
Yeah.
Very smart.
That's
Super.
What I end up drip feeding everything on both machines, mostly because that's what I started doing on the Fanic, because it's a Fanic and it doesn't have very much, memory. But what ends up happening is you can't search down to search like tool numbers or whatever, and so I end up posting out like the thing I do is I post the whole program, then I post the specific finishing operation that I need for that critical feature, and then I post the rest of the program. It's 3 different programs, and it works okay, but it is a little bit annoying. So I'm going to try that and see if that works. That's very smart.
Whenever we drip,
There's a way to skip down when you're drip feeding.
On the Haas there is.
No, on the Fanuc there is too. I don't.
Really?
Well, it's been years since I've done it, but I was in the same situation. I was drip feeding something at a company, and I was like, this. I was going back and forth reposting, and somebody's like, you can search down. I think you have to start it. I don't know.
I've heard that before.
Somebody that knows, comment. There's a way to do it.
Maybe you start it in tape.
Yep.
And then feed hold, switch it to edit.
It's something like that.
I wonder if that works.
There's a way you start it, and it gets your program in the machine, and then you can search down.
Because obviously you can't look at the program until you start it. Once you start it, code pops up and it starts rolling through. So maybe if you switch to edit while you're in there after the program started.
So the difference is that I'm not doing it in tape mode.
Oh.
Because I'm drip feeding from the PCI-MA slot. So it's doing an M198 call.
Oh, okay.
Like
well, that's the difference then.
M198, it's calling it from that card and reading it. So I have no idea. It might work. If someone knows, please comment and educate me, because this is the way that this is like sort of once you have a system and it works, like you keep doing the system. This is my nonstick pan of program loading. But I'm gonna try the block skip. That's a pretty smart idea.
Yeah. So when we drip feed, we always drip feed from the PCMCIA card,
right,
in tape mode. I don't ever do them one. Yep. But in tape mode, go to your programs. Usually, you have to go to programs, hit refresh, and then you have to highlight the program you want and hit DNC set. And once that's set, leave it in tape, press go, and it'll run.
Interesting.
Yeah.
I just have a sub program that basically, if I change the program, I just type in P1001 alter and then hit cycle start, and it just runs. So it's like you type in 4. It's actually faster for me to change programs on the Fanic than it is the Haas.
Yeah.
Like button press wise.
Yeah.
Because I just drip feed everything.
Yeah. It's probably about the only thing.
and that's basically how you helped us set up the horizontal here. It runs the same
It's
way.
the only way I know how to do it, baby.
Right, right, and it worked perfectly. So, a little bit back on topic here. I'm curious, Jarrett, so you got into machining kind of as a hobby, and it
Yes.
became, like you say, it's a hobby that got out of control.
Right.
At what point did you think, wonder if I can start making products for the industry that I'm actually in?
So when it was just a true hobby, I was already making products, I'm using air quotes for those not watching, products for the industry I'm already in because I was making stuff that I was using. Like I was like, oh, I want to solve this problem. And when you have a hammer, everything looks like a nail, right? So I was like, well, I'll just machine this thing and like make this little bracket to attach this thing to that thing. And then somebody I'd work on set with would be like, hey, can I get one of those? That's great. And then I was like, oh, sure, I'll make you one. And then that turned into, oh, I'll make 10 of them. And now it's turned into like, oh, I'll make 40 of them every 6 months, sort of thing. And that's how it goes. So it was like that. And then it sort of when people in town, there's not really in Los Angeles has been historically the center of filmmaking in the United States, right? That's Hollywood, that's what it is. Now with state tax incentives and things like that, it's become more spread. But there hasn't really been someone who does who is both a machinist and also understands how the film industry works in Atlanta as of yet. And so I'm sort of that person here. In LA, there are several of them who are machinists who have specialized in doing film industry stuff, that they understand. There's a bunch of weird specifications and like because there's German cameras, but there's American standards. There's a bunch of like, oh, it's a 3/8/16 hole that then has 3mm dowel pins around it. Is like a standard, right? So we're mixing units and we're doing silly things like that. Um, so what else ended up happening is people came to me like, "Hey, I want to solve this problem. Like, how can I do this?" Or there's a camera rental house in town that rents cameras to productions. I have a great relationship with them. Like, they will call me, once, twice a month, be like, "Hey, we have this issue. Can you come fix this thing?" I'll drive over there. I'll measure stuff. I'll make something for them. Oftentimes, same day. Bring it back over. Like, "Ah, thanks, great." And like that's a good client to have that they pay well, and I also provide them a service to solve these problems, as quickly as I can. So it's a thing that like there was quite a demand for it in Atlanta specifically. And it's a niche that I can both understand the intent of the product to be used and the standards it's going to be based around, and then also how to design and build the thing. And so it becomes sort of a one-stop shop where there are other people in the industry that have the ideas but don't understand the machining stuff. And that's fine, but then they need to find a machinist, and then they have to somehow communicate that information to the machinist. And so turnaround times become longer. There's things that are lost in communication. There are design choices that are like maybe not a little suboptimal because they're like, oh, you haven't actually used it on set. That sharp corner there is going to really suck when you stick your eye in the eyepiece and it's like poking you in the ear or something, right? Like, there's little things like that can really, help. So I think I went a little off topic on that answer there, but it sort of became it sort of as it was never like one moment that I said, "Oh, I'm going to start making products." It was a natural progression to, "Hey, I'm solving this problem. More people probably have that same problem. Let me see if people want it."
Yeah. Kind of like a unicorn of things. I mean, finding somebody who can, one, look at the problem, be like, this is what I need to do to fix it. This would make this so much better. And then also design it and actually design it in a way that's manufacturable.
Right.
But also it's effective. Like,
Right.
it just works the way that it should. And then from there to actually manufacture it, nobody really does that, it seems like.
Yeah, I mean, but that's sort of like that's the goal of some job shops and stuff, right? And that's the reason that some places exist. And it's literally like, I guess in a way, all of my clients that do that are like yahoos, essentially, right? In the larger definition of yahoo, right? Because all it is a farmer coming in and saying, "I have this problem. You all have the skills to design and fix this problem and the capacity to do so. Fix
Yeah.
this problem for me," right? The difference is that my yahoos are, hipster camera guys in Atlanta, not like farmers with John Deere stuff. So
Right,
the
and they
stuff's
have
less
plenty of
dirty,
money.
Yeah, and they have a little bit more money at times, yeah. But that's essentially like my whole business is based on, is like people having these problems and either me coming up with solutions in the field to problems that I have and then marketing those things, or people coming to me and saying, "I have this problem. Can you help me fix it?" And me going, "Yes, let me design this thing. If you have that same problem, I bet other people do too. Let me make
Yeah.
more of these." And there have been some that I've made, initial runs for stuff I'll generally make like 10 of stuff. And there have been times where I made 10 of something and I have sold 0 of them because it turns out no one else has that problem, and it's just that one guy, and that's it, and that's okay.
You got products on a website or?
Yeah, it's possumsolutions.us is the website. And the reason that is that .com is a possum removal service. So .us was the way to go.
So if you need removal service,
Yes, exactly.
product US.
Yes,
Wow.
exactly. The website isn't great, but it's sort of you can get an idea of like sort of the parts and stuff that I make. None of them are that complex. Like I'm going for simple, effective, relatively inexpensive manufacture. But I think
They
some of
look
the parts still look nice. Like they're not bad. But I also have sort of going on the building my own products thing. I have the distinct advantage of also designing the stuff myself. So like I am giving myself fillets inside of corners, and I am making things where they're square on 2 sides to hold them on two, and I am like the things that end up being like I don't have to argue with an engineer.
So
right?
you're
I
a smart Imagineer.
I'm a what?
A smart Imagineer.
Imagineer. Yeah, sure. Yeah.
You can imagine the process and actually making a product that is machinable.
Right. And I have a bunch of people that I've sort of introduced to Fusion or introduced to things, and they'll design stuff, and it's awesome. I love having friends who want to make stuff and want to solve their own problems, and they've seen me do it, and they go, this is awesome. And generally they stop at 3D printing because A, 3D printing has gotten so good, and B, it's so much easier than machining. Like
Sure.
you can put one in your living room and your spouse is not going to yell at you, as opposed to putting a CNC machine in your living room. You'll probably get a divorce, right? Like that's the, but then oftentimes they'll be like, hey, design this thing. Can you machine it? And I'll be like, yes, but does this actually need to be this way? Oh, no, that's fine. Okay, great. Does this actually need to be this way? Oh, no, that's fine. Like, okay, I'm going to redesign this for you. And then I'll make it for you because it will be faster for me to redesign it than to figure out how to make your thing that's optimized for 3D printing. And they also have relationships that like, those are constructive conversations that the next time they don't bring the same problems. Right. So like now
all engineers can have that thought.
Yeah, exactly. And like, I'm not mad about it. It's the nature of learning how to do stuff. It's really easy in CAD. You all know this. It's really easy in CAD to draw shapes that are not machinable.
Yes.
Absolutely.
And
we know that, but a lot of designers don't.
Right. But no one also knows it until they know it, right? So it's that thing of me coming in, and if anyone's watching and hasn't seen it, Adam the Machinist on YouTube has an incredible series on design for manufacture. Like, it's the best, simplest laid out with good demonstrations and excellent, well thought out things that are absolutely worth a watch if you had ever designed for manufacture. They are fantastic.
Is he the guy who has like a garage at his house with all the he's got like a tiny track mill, I think?
It's a Mori.
Oh,
yeah.
Not.
No, it's like an early 2000s crazy accurate Mori.
Like the square
tiny travels. Yeah.
Up instead of over. I think he's got a really small lathe in there too, right?
No, I think he has a mini mill, the Mori, and like a couple of grinders.
Okay. It's been a long time.
Maybe you're thinking of a different person, but beard.
Yeah. Big,
crazy smart. Like insane. But highly recommend that series of videos to anyone who's watching. It's just, if you search Adam the Machinist on YouTube, he doesn't have that many videos, but there's some design for manufacture things that talk about like length, diameter to length ratios, right? And corner rounding in mills, and like what fillets are expensive and what fillets are free, and like simple stuff like that. It's like, okay, I want to make a hole. How are the ways I make a hole? And what are the cheap ways to make a hole? And at what point do they become more expensive? Sort of that like very simple stuff, but from someone who clearly has made a lot of things really well, for a long time.
It's always amazing when you get parts and it's just like, where'd you come up with this? Like, what are you doing? And I get them from the same customer, different engineers. Like, I got a part right now. It's got a lot of inside radiuses, but they're all like 10 thou big than a nominal size. So like, it's like 135 corner radius or a 406 corner radius. Like, I can go in there with a 3/4 end mill and just take it out. It's perfect. It's fucking awesome.
Yeah. It's amazing.
Yeah. And see, I'm sure a lot of us, we do that for ourselves, but a lot of other engineers don't think that way. They just assume put a nominal size there, it's good, because they don't know. No.
Yeah.
But they also don't know until they know. Right?
Exactly.
Like I can't fault someone for not knowing how my thing works.
Yeah.
all I can do is work with them to be like, hey, next time, just let you know, this is easier if you do the XYZ. And then after that, if they say, no, I'm going to do it the way I'm going to do it, then you're like, okay, maybe you should find a different shop. Like, maybe you should.
I've said this before, man. Communications with your customer is key. I've reached out to so many and
Absolutely.
been like, hey, you got this 125 radius going down 2 inches. Can I bring it up to 160 or 200? And yeah, not a problem. And then
Right.
they'll ask why, and I'll explain it to them. And now I got one customer, when they send me prints or CAD files, they send me the whole assembly, so I can actually see what this product
Amazing.
is doing. So then I'll see a corner that's irrelevant, doesn't make a difference. I'll blow that thing out with a 3/8 end mill, and they don't care.
Right.
As long as
And-
it doesn't interfere with the assembly.
And that goes exactly to like what I'm doing, and why I think I'm sort of a bit of a sweet spot is that if I'm designing my own stuff, I know where it's going to, I know what
Yeah.
it's interacting with, I know what matters and what doesn't matter. And so I don't do very much like people have job shops have like shop tolerances of like, oh, everything's plus or minus 5 thou, whatever that. I have like the tolerances literally do not matter until they do.
Yeah.
And I know the ones that do and I know the ones that don't. And if they don't matter, I don't measure them because the machines are good enough. It's going to be within 10 or 15 thou if I like am really bad at what I'm doing.
Yeah.
And if they don't matter, they don't matter. You know,
Yeah.
but I don't know.
Written function is key sometimes.
Yeah, exactly. If it looks good and it fits and it works, everyone's happy.
Yep. Yeah. So have you done a lot of work? Have you made parts for anything outside of the film industry?
I have. I've done a little bit of job shop work for some friends who needed like parts that when I had a little bit extra capacity. And it is the most stressful parts I've ever made because I have no idea what it goes to, and I have a print that says plus or minus 5 thou, and I go, oh crap, okay, everything has to be plus or minus 5 thou. Oh god, okay, I know that's not tight, but also like I want it to be perfect. So then I'm like measuring every part, I'm comping things in, I'm doing things, and the parts look great and it works well, but it is so much harder.
Right.
I know I sound like a really like stuck up, privileged, prissy machinist over here, but it is a lot harder when you don't know what's going on because everything has to be to print because you don't know what matters and what doesn't matter.
Right.
And so you want to make it right. And not to say that my parts aren't right, it's just our definition of right is different.
Do you have 3/16 thread gauges?
I do.
You do.
What class are they?
Well, I've tried. That's been my last like six to 8 months has been slowly buying a bunch of metrology stuff. Because it is as I do more parts that need to be more precise to fit with each other, or larger assemblies that I want to fit repeatably. That's sort of been my limiting factor. Is okay, I can measure with a pair of calipers, but if I'm doing this dovetail fit, I really need something different. And so I think at Black Friday sale, I think I bought like the Haas manual micrometer set from like 0 to like 300 millimeters, like the whole thing. And I'm sure people will flame me for using metric, but that's what most of my stuff is designed in. So that's what I use. And it's been invaluable to be able to be like, oh, I got internal bore mic set up from like, I think 12 to 50 millimeters or something. And so it's like I'm doing these parts right now that I'm trying to do carbon fiber fits into, a press fit aluminum piece, and being able to dial things in and having resolution of, half a micron is like, oh, I can do this way better than doing a snap gauge. And then, the thing that it's like, that's not 3-point bore mic turns out is a lot nicer, and
Oh yeah.
it doesn't have to be like crazy high end Mitutoyo stuff for what I'm doing. Like I don't actually need it to be plus or minus 5 microns, but I can very repeatably go for my own stuff. Okay, I know I want to hit this range. I know this range is going to be good, and now I can very quickly and accurately measure stuff. So that's sort of been, I think, the thing that has really got me to sort of where I feel like I'm almost a real machinist now. Not quite, but I'm almost a real machinist now, is like actually having metrology stuff and like actually measuring things. Really like measuring things accurately, and repeatably. And like it's easy to make one of something. Can I make 30 of something that all fit well? That's the harder thing for me to do, and the place where I need more of that process and more of that metrology stuff.
Yeah. And usually, I mean, well, and especially with aluminum, once you've got it figured out, once you prove out your first part and you got everything dialed in, you can just
Totally.
let it rip. How are you measuring those dovetails? Are you using like ball bearings or
Dowel pins.
Dowel
Yeah.
Mm.
Yeah.
Yeah. thankfully, like dowel pins and micrometer is generally how I'm doing it.
Yeah.
Seems to
No,
work decently well. If people have other ways of doing it, please let me know. But that's the only way that I know how to measure dovetails.
I'm not really sure of other ways to measure it. That's just the only way that I've ever seen to do it.
Right.
I'm sure somebody's got some sort of like fancy setup for measuring dovetails somewhere. But
Right.
Well, if you have the time and you make a lot of dovetail parts, you could look at making it like a go no go gauge
Right.
that is
Yeah.
just the minimum and the maximum tolerance of the
Mhm.
dovetail, but just depends on how much of those you're actually making.
Unfortunately, the film industry is a bunch of different manufacturers, and historically they've been a bunch of different standards.
Yep.
And we've converged on a couple of standards, but then now there've been other manufacturers who have come up with new standards, which is fun. And so there's like 7 or 8 or 9 different dovetail sizes that I make, depending on what the part is, which is a bummer.
Mhm.
And even within the same dovetail range, like Steadicam, the thing I do at the top stage, you attach the camera to a dovetail piece that clicks in to the top of the sled, the Steadicam piece itself, and that is a dovetail piece. And there are probably like 6 or 7 different manufacturers that make that top piece that different people use, and they all, quote unquote, again using air quotes, use the same dovetail. But if you buy a dovetail from one manufacturer to another manufacturer, they are not the same. So if you do that pin over pin distance, they're all 60-degree dovetails. That pin to pin diff distance I measured 4 or 5 of my different plates that I have from different manufacturers, and they can vary as much as like 3/4 of a millimeter, which is pretty decent thing. And like a
Yeah.
dovetail fit, like that's a
That's a lot.
pretty big difference.
Yeah, I mean, that's like 27 thousandths for us
Right.
Americans.
Yeah, like, and so it's that thing of like, okay, which standard do I go to? If I want to make a plate that works with everything, like, do I just split the difference, go in the middle, but then it's going to be too tight on some, and then some of those top stages are adjustable, so you can adjust the tightness, and other ones aren't. So then do you make it's a whole thing to figure out, okay, how. And it's also thinking about clearly, if it's that much range, the tolerance doesn't matter that much, right? like if it's that big of a spread, but I don't know.
What you should do, Jarrett, is you should come up with your own standard, and then that way people have to buy your product.
The Possum standard.
No.
Yeah. Come on, man.
That's all we need is more standards.
Exactly, right.
No. What I do is I find the standard that I really like and then only make parts for that standard. And so hopefully promote people to use that more.
Mhm. Like making everything you make in metric.
Well, I mean, it's just the reason I do that is because a lot of the parts in the industry are metric. The
Yeah.
main manufacturers of cameras are German and Japanese. And so that's,
Makes sense.
they're metric people.
Right.
metric people. Even your machines are metric.
All machines are metric, yeah.
Yeah.
Also,
Oh, really?
everyone's machine is metric.
Yeah, that's
like,
true.
Like the ball screws on your machines, you like Haas with your American-made machines, they're metric ball
Now,
screws.
hold on. I got a 1937 South Bend sitting right here. That thing ain't metric. You take your millimeters and shove it, buddy.
Also, if you want to go even deeper, the imperial system is based on conversions from metric standards. So if you really want to go to it, like the meter is no longer a physical definition. The meter is defined by like the wavelength of light in a certain basically it's by like a physical construct that cannot change, right? Because if not, it could change, and then the standard of a meter would change. And the inch standard is based off of that meter standard. So SAE is just boy, I'm gonna get so many comments for this, aren't I?
Oh, yeah.
I have just got myself canceled in the machinist community.
Butterfly.
Let's be honest.
They have a
Metric
short.
Metric is easier.
Yeah.
I mean,
Not for
But-
me.
well,
There's nothing wrong with it. Like, you can do the same thing in both things. There's nothing wrong with either one. I grew up in 3D printing. I grew up in metric. That's what my brain thinks in. So that's what I machine in. Yeah. Don't attack me, please.
that's funny. So, I mean, let's go ahead and kind of do the pull back the curtain on the big thing here, Jarrett. You have a robot.
I do have a robot.
You're a one-man shop with a robot.
Yes.
How and why?
So, let's go into the why first, and it's twofold. One why is that robots are cool, and they're fun to play with. And I
Yeah.
thought it'd be fun to play with one. And this is a hobby that's gone overboard. And the why too is I went to IMTS this year. I ended up meeting a bunch of y'all, a bunch of the people on the Impractical Machinist chat. Pat was not there, notably.
No, I was not.
But there was a bunch of robots. I mean, as everyone said in all the YouTube videos and everything, that like automation was a big theme there. I work on set and I don't have a lot of time in the shop, and I like the idea of having more time or more machine time to make stuff as I'm getting busier. I was walking around the IMTS and looking at different options, and they're all, the cheapest one was 80,000 ish, and they would just went up from there. Like anyone who was there that saw the lights out machining demo was incredible. Like just like different size stock and the automatic vise that's air actuated, all that stuff was like incredible integration. Zap was involved with that, and the lights out people clearly are like, if you talk to people that have used them, they're just like, yeah, you call them and it's turnkey, it's white glove, you're set up, you're good. It's also like $185,000, right? Like I
Right.
don't have that money. I spent, less than 25 grand on both of my machines, each. And I am not going to spend that much money to put a robot on them. So I ended up walking around at the very, very, very back end of the main hall was productive robots. And they had a little demo parts that was setting and stuff, and I went over and played with them. Their like mill tending kit is like 37,000. It's a 7-segment robot, lifts 5 kilograms, about 11 pounds, has about a meter of reach. It is made in the USA, which is kind of cool.
So why are you talking in meters and kilograms?
I don't know, but because that's how they spec it. I don't
Mhm.
I don't know.
Huh.
But also, I mean, even modern American cars are all metric fasteners. So it's like, anyway, I digress. So played around with it, super easy to program. It's drag and drop on an iPad or an Android tablet, basically. And I was like thinking about it, I was like, okay, 36 grand is a lot, but it's not like undoable. If I think about how much time and everything I was thinking about, I was emailing back and forth. I got the CAD model from them and put it in my shop. I have a very small shop. It's like 385 square feet. And so I was like, "Is this gonna fit? Am I still gonna get to the machine?" Da, 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 da. And then I was like searching on eBay one night, and there was a used one for 20 grand. That was like basically new in box. A company had bought it 2 or 3 years ago to do it for a project. That project didn't happen. They set up to play with it. They put it back in the box, and it's just sat. And I went, we just offer him. I think they were asking 25 grand, and I offered him. I was like, "Oh, just offer him 20 grand and see what happens." And I wake up to an email, be like, "Hey, great, so you owe us money now." And I'm like, "Okay, great, I bought a robot. Here we go." And so it got in about Thanksgiving. Started playing with it. Crazy easy to set up. Like I think I had my first program like running on it in maybe 45 minutes after unboxing it.
Mm.
Like not making chips, but just like picking up this part, putting it over here, like sort of thing. It's a little deceiving how easy it is because it's bearing the lead of the actual things that are hard with it, right? I then went and did a show, came back, and in December, January did the actual integration. So they pitch it as a parts loading robot mostly. The kit comes with an air vise, a chip fan, the robot, and then the robot comes with a little table that basically the idea is you lay out in a grid pattern. It picks the part up, it puts it in the vise closes, you do the part, it picks it up, puts it back. I love that for if you're doing 80 to 100 to 200 parts or whatever. That's great. I tend to do much smaller runs than that, and I also tend to do slightly more complex parts than just 3-axis parts. So my thought was I could get 2 pneumatically actuated 0-point systems and do pallet loading, and then use the robot to take the pallet from the 3-axis 0-point plate to the 4th-axis 0-point plate and do fake 5-axis basically. So I can access the top of the part on the 3-axis, I can put it on the 4th-axis 0-point plate, and I can access all the other sides of it, right? And so I was like, okay, I'm gonna do pallet loading. Let me figure it out. So I'm using the little like EDM cheap China vices. And I think right now I have 8 pallets, and I have enough stuff to do an additional 4 to do 12 total pallets. And I use like 40/40 aluminum extrusion to make the vertical pallet system with 3D printed racks that they slide in. Um, and it seems to work pretty well. Like it's been running since I got back from the movie I just got back from. You know, it's run 5 nights out of 7, I want to say. Like, and it's run. Last night it ran 6 hours after I left the shop.
Yeah.
Sweet.
And it's massive. There's no way I would get enough stuff done if I did not have that in my shop right now. And at the same time, it took me 3 weeks of like pretty constant work to, you know, get it where it was running reliably.
Yeah.
So it's not a like easy, I was trading off time and interaction for money, but I bought the robot for 20 grand. I bought the 0-point plates. Were a Chinese company called Silver CNC, which I have their probes and their 4th axis, and I trust them. They do a lot of really actually quite good products. I have been really public about this whole process as I've been doing it, just like sharing Instagram stories, and I've had a lot of people who I have been really, really thankful have like way more automation experience than I am, because I'm just sort of like brute forcing my way through it. And they have offered suggestions. And one big suggestion was don't have the robot open the door. It's hard on the joints of the robot, because even though the force needed to move the door is not more than the capacity of the robot, the inertia of the door can be. And so you end up wearing the joints quite a bit as you're opening and closing the door. And they're like, it's not, I think the auto door was maybe $150 in parts. It's just a pneumatic cylinder, a Hall effect sensor to know that it's closed, so that so does the machine. Like if the door isn't open, I don't really care. The cobot's going to hit the door and error out. Like no harm, no foul. If the machine turns on and the coolant turns on with the door not closed, it's a mess, right? So I care more about the door being shut than being open. Hall effect sensor and some wiring, some tubing and a pneumatic solenoid. Like that's all it is. I designed a little custom bracket that screws the top of the door, just machine out of aluminum. Yeah. So
how do you make the machine tell the door to open?
So the robot does. So right now, the way it's all hooked in, the machine it's on is a Sharp 2412 SX from 2011. It has the higher end FANUC control at the time. It's the OIMD, not the OI Mate, which is the one that happens. The distinction is important because the OIMD can handle a 4th axis, which is nice. And also, it's set up. The ladder is set up in such a way that it can either handle a full 4th axis or a 4th axis indexer. And so the way the indexer would work is it sends an M-code start signal out, and it waits for the indexer to finish the M-code with an M-fin signal, M-code finish signal, which is also a really common thing on the Haas machines. I kind of got lucky that this FANUC machine was set up with that option. But so basically what I'm doing is when the way Productive Robotics tells you to set the robot up is you basically wire in a little relay into the cycle start button, and when and then you wire a relay or a signal out of a M code, and so the machine's done, it sends an M code, and when the robot's done, it cycle starts the machine. There's a guy, he also has some Productive Robots and does awesome stuff. He was messaging me and was like, do not give the robot that much authority. You do not want the robot to be able to hit cycle start. You want the robot to only restart the machine when the machine has called for the robot to do its thing. Because you don't know if you're inside the machine doing something and there's some glitch or whatever, or like the robot decides it starts to do something and all of a sudden the machine cycle starts, right? On some random program. Like, do not give the robot as little authority as possible. And I was like, that's very smart. So basically, yeah, exactly. So they suggest that. I think the idea from I'm sort of pushing the Productive Robot a little bit further than I think a lot of people do. Normally it's just a parts setter up. It's not trying to do a pallet pool. It's not trying to do all this integration stuff. But basically the robot is doing all of the actual loading and controlling everything, and the machine is just outputting an encode, and that's all it's doing. So the way it looks like on the machine, I have a program that is the robot run program. It's program 100, just because arbitrarily. And so the first line is it calls the sub program from the card of whatever program I'm running. That sub program M99s back to this main program. The next is program 111, which is my blow off program. And so it calls the chip fan. It waits a second, and while it's waiting, the chip conveyor comes on for 30 seconds to clear the chips out. And then currently it waits for like 90 seconds to let the coolant stop dribbling. I need to figure out a better solution for that, but right now it's just waiting. And then it runs the chip fan program, and then it goes back to the main program. The next program is the robot call program, and that robot call program subprogram moves the machine table to the same position every time, so it matches the robot thing, and then calls the M code for the robot. Once the robot's done, it closes the door, it finishes that M code, and then it comes back to this main program on the FANUC, and then I call the subprogram that uses the probe to check that the pallets are seated correctly. And all it's doing is it probes the four corners of the pallet, and then probes the four corners of the pallet on the fourth axis, and compares the position of that. And as long as it's within, I think I have it set as long as it's within like 5 thou or 10 thou, it says it's good. And if not, it'll error out. Amazingly, I have had 0 problems with take it back. I've had 1 problem with a pallet not being seated, and it was during my initial testing. It has been amazingly reliable in terms of when I'm actually running production. It has never errored out for a chip, for anything like that. Like the combination of the Sharp has like a really powerful coolant pump, so it's really pushing a lot of coolant things, and then the blow-off fan, I've had 0 issues with that. It's been really amazingly reliable for what it is. But that's sort of the rough breakdown of how I have it programmed right now. Again, I don't know if this is the right or not. This is just like the brute force way that I figured it out that is working.
One thing, so with your coolant dribbling, is that dribbling from the actual coolant lines?
Yeah.
So you can put a check valve in there.
Yeah.
As close to the coolant lines as you can, or as close to like the actual nozzles as you can. Put a check valve in there, and obviously the one-way flow, or so when the pressure's off, it'll close essentially. So it has to have pressure to open. And then
So yeah, I was looking into this, and someone find me this valve, because all the valves that I found are you one-way flow. You want the flow to go from the coolant pump into the nozzles, right? And so the idea is that in that check valve, it's a ball bearing overcoming a spring to get off the seat and allow coolant to flow over it. So what you need a spring that's stiff enough to resist, let's say, 3 or 4 psi, so that it won't dribble, but weak enough that when the coolant pump comes on, it opens up.
Yeah.
Every one that I've been able to find, and I sure I'm not exhausted. So if someone has this check valve, please send me it, because I want it so badly.
Did you try the lock line ones?
Yeah, it's not.
I was
they
gonna
don't-
say I tried them because mine
doesn't
would drip
work.
too, and they continue to drip.
Yeah. So, like everyone that I found, the cracking psi of the valve is like 0.3 psi or something. Like and I did the calculation of basically what's happening is obviously like the coolant line does a big loop as it goes up to the z-axis, and so it's the head of coolant above that's flowing down through the things, and so I've done the math of like, okay, it's 3.5 feet, 9.8 meters per second squared. This cross section of the hose gives me about this psi, and it's about 5 psi. Basically, check valve wise, I need a check valve that'll like be able to withstand 5 to 8 psi of pressure, but will allow more than that through. I haven't found it. If someone wants to find it for me, I will buy it in an instant. It'll solve
Have you
this problem.
tried to shut your coolant off when your head is down and give it a pause and then go up, so it has enough time for what's in it to drain out, and then when it goes up, you know what I'm saying?
Interesting.
I worked at a shop that's what they would do. They had a pause.
Interesting.
They'd shut the coolant off because it dripped. It was a terrible drip.
Yeah.
You would have to wait to swap parts. They didn't have a robot or anything, but
It's
it went
annoying.
up, and you open the doors, you got in there, it was just spinning.
Ah.
So they would put like a 10-second pause, so it would come up to its clearance height, pause, coolant off, 10 seconds, and then go up.
Interesting. Yeah, right now I just have I have a weight code in the chip fan program, and it's working fine. I'm not here when the robot's running, so I don't really care. But it does add up if I'm doing 80 parts and I'm waiting a minute and a half each.
Yeah.
That's real time.
It is.
So right now it's not like real time because it's time that I'm not here, so I don't really care. But I also do run the robot during the day, because it is nice to just like not think about it. I walk over there every 4 hours, I reload parts, and then I keep going, which I'm sure Brad you can relate to with your pellet pool.
Yep.
It's like, boy, it's nice.
It is.
Oh,
My horizontal actually does that too. So when my program's done, so my tool will go up and over, and my top 2 coolant lines, they just drain like crazy. It's probably a minute. But I found that I have a second home on there. If I send it to the second home first and let it sit there for a little bit, I can open the door a lot sooner and check it.
Interesting. I'll have to play with that. I'll definitely play with that. It's an interesting idea. The other thing that I think is the solution that I haven't done just because it's a little bit more wiring and a little bit more annoying is to put a solenoid valve right next to where the coolant lines go. And this is what Brother does, right? Like Brother for tool changes doesn't turn the coolant pump off. they just close a valve and deadhead the pump during the tool change so that you have immediate pressure again because it's such a fast tool
Ah,
change.
that's
Hmm.
cool.
Yeah, which is really cool. And so I just have to have a solenoid that just is wired into the same output as the coolant pump, right? So when the coolant pump's on, the solenoid's open. When the coolant pump's off, the solenoid's closed. Like it could be as simple as that.
It seems like a pretty simple solution.
It does. The reason I haven't done it is because it involves wiring it, taking off all of the sheet metal on the head and wiring in, through the loom, a wire into the solenoid, wiring it in.
Yeah.
And I have parts to make.
Just good Bluetooth solenoid.
Nothing, yeah. But like that's the saying is like nothing is more permanent than a temporary solution,
Yeah.
right? Like that is the definition of like right now the Hall effect sensor for the door shut thing, right? It just needs a piece of iron, and so I grabbed an old like T-slot T-nut that I had lying around and just like put a big washer, just screwed the T-nut to the top of the door. So that's the Hall effect sensor thing that works, and it's been like that since like mid-January.
Yep.
And it works. So like, why change it?
Yeah, what's the hurting?
T-nuts are cheap.
Yeah, it's also like it came with my vices, and it's like too big of a size for the T slots I even have, so it's just literal trash for me. So, reduce, reuse, recycle, right?
So, if that thing actually runs for like 2,080 hours a week, standard work week,
A week,
it's gonna
2,080 hours a week.
2,000. How many hours do you have in a week, Pat?
excuse me, sorry, a year.
Okay.
That's a cost of right at $13 an hour, and
It's not bad.
no, and I'm sitting here thinking in 2025, any machine shop paying their operators $13 an hour needs to be burned to the ground.
Right.
So that's amazing to me that, and mind you, you did buy a used unit and everything, and you did a lot of the work yourself. But even at that, if you spent 40 grand on a new unit or 50 grand on a new unit, it's just amazing how the barrier for entry for that kind of thing has come down so much.
Absolutely.
So,
Well, the return on investment over an employee is there in 2 years.
oh yeah,
Yes,
at
and
least.
I will to push back on that a little bit. It's not a replacement for an employee.
No.
And I say this as someone who has had a buddy come and help me at the shop recently. He's doing a bunch of shipping for me. He's doing some customer emails. He's doing some cleaning, some organizing. It's awesome. He is great. He like wants to be here, wants to learn, wants to do stuff. It's awesome. The robot only does what I tell it to do, and it can only do that one thing. And it does it really well, and it does it repeatably, and it doesn't complain. It doesn't take bathroom breaks. It doesn't require healthcare. But that being said, it helps me in my specific situation, and I think it would help other people in their situations, but I don't think it replaces an employee. I think it is a force multiplier for a single person to be able to have more hours in the shop.
Yep.
Mhm.
But a good machinist that like I could pay, if I went out and I don't make enough money right now in this business to make it worth me paying $80,000 a year for a really good machinist in Atlanta, right? Like that's like I'm assuming that's about what it would cost to like hire a somewhat decent machinist. It's not just a button pusher, right?
Yeah.
That person could generate so much more value for me than this robot could, right? Like I could then I can't hand the robot a print and say, hey, make this, right? Like I can't tell the robot while the machine's running to sweep the floors. I can't have the robot help me organize the cart or come up with ideas. It's a force multiplier for the amount of time that I have. It gives me more time to do the things that I want to be doing and lets me
Mhm.
make more parts. And for me, it was an excellent decision. Someone had a question in the chat of like, do I get a cobot robot set up or do I get a second machine? And my answer to that is absolutely the second machine if it's an either or. The robot might be cheaper than a second machine, but also I spent more on the robot than I did the DT, my Haas. Like I did.
Sure.
Like I have, and the difference is at one point the Sharp had an issue where like a relay went bad and the tool arm wouldn't work. And I had to wait like 2 days to get a new relay. Wasn't a big deal. It's a standard part number on DigiKey, really easy to diagnose, easy to fix, like a literal $12 and 2-day fix. But for those 2 days, if I only had the cobot and the one machine, I would be down. No parts being made. Instead, I was like, great, I'll just make this rush part in the Haas. No problem.
Yep.
Right? Or like there is leaving the setups, like right now the Sharp is just set up for the fake 5-axis thing, right? 0 points, these pallets, I have one bigger vise for it, but like that's all it's set up for, and that's all I use it for right now. And so if I do weird setups there in the Haas, and I don't have to change the cobot setup for any of that stuff. So the cobot's great, but it's like not this magic. Like I feel like a lot of the people that are selling automation are selling this like it's a magic thing that will like buy you all this time. You don't have to hire employees anymore, and you just do other stuff. And like it does buy you a lot of time. And like
No, I think looking at it as a force multiplier is definitely the right way to look at it. And
Yeah.
even if you do have an employee, giving that employee a functioning robot, I mean, it's a force multiplier for them. Now that
Totally.
employee's, making you double the money they would have made without it. So
right. And or just not sitting in front of a machine reloading parts. Like that's boring.
I know.
Oh,
They're-
Like
they're-
let them use their brain.
Exactly. They're doing something effective somewhere else.
Yeah.
Yeah. Which means you
Also-
end up paying them more.
Also, it depends on your parts. Like Cam, your parts, a robot's not going to work very well. You have to have a very large robot
Exactly.
to like actually make your parts worth it. And you're doing onesie twosies and stuff a lot of
Exactly.
times. It's
Yeah.
like
Yeah. So
If we-
what you might say then is it depends.
yeah, it's
depends.
as everything does.
As always, it depends. Yeah.
Life is not a black and white thing.
I think if we were to do a robot, it would need to be similar to your setup. So it's
Pallet pool.
essentially a pallet pool. It needs to be loading pallets or vices.
Yep.
Something like that. Just because our stuff varies so much. Like some days we might make a quantity of 10, and it's like it would be really cool to have this already set up, ready to go. You proof out your first part, but like the loading part does not change as far as loading
Right.
devices, right? You just say how many
Correct.
times it's going to happen. So it's like,
Correct.
all right, I got my first one proofed out. I know everything's good, or maybe it's a repeat part. It's going to be good. All right, cool. Now just do that 9 more times. I'm going to go do something else versus having to stop what I'm doing every 10, 15 minutes, coming back over here, swapping parts, blowing everything off, putting in a device, all that stuff, inspecting it, just making sure everything's still good, going back to what I was doing. I could just ignore that altogether.
Right.
It's like, oh, look, all 10 parts are done. I'll go set a pop 2. So I think that's where it would help us. Because even with 10 parts, if you're doing it that way, even then a robot's helpful. Which I mean that's kind of what you're doing because
That's
how
exactly
many did you say? How many vices do you have set up?
right now 7.
Yeah.
Or 8. So I specifically chose the pallet pool style versus part loading because of low quantities and because what it means is I only have 2 programs in the robot. I have a 3-axis and a fake 5-axis program. And so either it's only loading the 3-axis back in and out, or it's going to do the fake 5-axis. And the robot programming doesn't change. I have a template infusion that has the vice already on it with the pallet attached. That's the right height. That has parametric stock for whatever I bring in. It already has my template on there. I'm never probing anything except for probing for verification that the pallet's seated. Like it's like as long as I'm working within the envelope of this robot, which right now is about 4.5, 5 inches long, about 2.5, 3 inches wide, and about 3 inches tall, which is not a huge operating envelope, but it's plenty for the parts I'm making.
Yeah.
And under 5 kilograms, which it very easily is, I can just pop parts in, proof the first one out, and then press a button and walk away, and it will run them. And boy, that's nice.
That would be awesome. I think we would definitely have a higher barrier for entry considering the size
Weight.
of what we would
Yeah.
need. Yeah, weight. I mean, majority of what we make is not aluminum. So would definitely need a robot that could handle some more weight. But if you figure that part out, which I don't know what that turns into.
Money.
Yeah, of course it's
You can solve all this with money, Cam.
Is it turning into like now we have a big caged in robot cell outside the machine because we need a big robot?
Right.
What does that look like? Really what I would like is to have it on the side of the machine and load through that side window.
Yes.
Then you can just send the table over there. It can load it, do whatever it's got to do, and then continue that way, because we're doing so much job shop work, onesie, twosies, and stuff like that, and then occasional 10, 15, 20, 30, 100 parts. Whenever we do need to switch to, robot mode, it's off to the side doing its own thing. But then whenever you need to go back to job shop mode or just setting up and proofing stuff out, because that happens every single day, the stuff in front of the machine doesn't change. So that's still efficient and effective the way it is now. So I would think that's how we would need to do it. But yeah,
Have you ever looked into the vertical pallet pool machines?
Vertical pallet pool machines, like the Haas ones that the whole table changes out.
yeah, those are cool.
Those are cool.
I mean, that would be
They
an
take a
heavy
lot
plate.
of space.
They do,
A lot of space.
but it's off to the side.
Mhm.
I don't know if your parts would fit in.
I would say,
but
I would say the thing that I wouldn't be crazy about with that is like, I could set up 100 vices outside the machine ready to go.
Yep.
I can't do 100 tables.
Yeah.
Granted, you can put a lot more vices on one table. So there is that.
well, how big is that robot going to be with 100 vices to set up?
I don't think it would take up as much room as the big
It
pallet
wouldn't.
tool.
But again, it's just like how big of a
Convert it
part
there.
are you putting?
Yeah,
Are
I'm
you
thinking
on a
you got
machine?
big parts though.
You got big parts.
Well, we're not gonna. I mean, that wouldn't be something where we're loading, 15-inch diameter, 20-inch diameter parts. I'm thinking stuff that can fit in vices.
Okay. That
So
makes
How
sense.
much of that do you do, Cam? Like, how much of the stuff can you do that fits in a 6-inch vise?
a decent amount.
Yeah.
I
Okay.
would say 2/3 of our work is in,
Oh, okay.
maybe even
So
more.
you just post the cool stuff then.
Yeah. I guess I was just assuming you guys always did big ass.
I assumed everything you did was like the size of me.
No, so
Like,
yeah, our 3 mills are one's a 40 by 20 table, another one's I think 40 by 22. And that's the BVM, that's the bridge mill, but it's always got a fourth axis on there. We don't
Right.
ever take it off. We never really need to. If we did, we just put it on a different machine that doesn't need it. But so that's realistically like a 30 by 20 table, maybe. And then we've got our D&M 4500, which I don't exactly remember the travels off the top of my head. I think it's like 32, 34-ish by 17 or something. So it's small too. And then we have the D&M 750L, which is 85 by 30. And
I
as
love
far
how
what?
I love how Cam's like small machine has 10 more inches of X travel than my biggest machine.
Yeah, I guess that's true. Yeah. But
When your parts are big, you have a different perspective on things, you know?
yeah.
Um,
But then as far as lathes go, though, which we kind of have a big gap between our lathes. We have
Right.
one that's 8-inch chuck.
Johnson,
We got
right?
a 20, the Johnford, Johnford
Johnford, sorry, yeah.
SL300. So that's got an 8-inch chuck, and they're both just basic 2-axis lathes, no sub
Yeah.
spindle or live tooling or anything. One day, but 8-inch chuck, and then we've got the Puma 5100 that has a 24-inch chuck.
Which I've been to your shop, and that lathe is terrifying.
It's awesome.
Like, it is awesome, but I was like watching Sam run it when I was there, and I was like, you're spinning around like a 500-pound piece of
Oh, yeah.
material, like even at 300 RPM, like that's a lot of like
Yeah.
inertia.
And whenever it's the first time you're spinning up one of those giant burnouts, it's like 4, 5, 6-inch thick burnout, and at 22 inches in diameter, and the kerf angle on those things is never straight.
Right.
It's
Yeah.
always angled out, and then like angled out on one side,
Jesus.
the angled in on the other side. And so when you're watching, I mean, it's like it looks like you have one of your jaws off because it's just kind of like,
Jeez.
I don't know,
Yeah.
like a lobe effect. I don't know.
Does it have to be like anchored to the ground or anything for like the
That thing's pretty heavy. I want to say that thing's. I mean, I want to say it's over 20,000 pounds. It might be 25,000 pounds. It's a heavy lathe. I remember
Okay,
that.
yeah.
But that being said, you do still feel it sometimes. Like when you load up one of those big burnouts that's really off balance, you can feel it. There's also some parts we make that get a big flat cut on them, so it's like 23 or 23 inches in diameter or so, and it's a weldment, and so you've got your like an outer ring and a kind of a plate in the middle, and then a big boss that gets welded into the middle, and then it's got a water jacket on the back of it. So all this stuff gets welded together, and you rough machine it all, weld it, then stress relieve it, and it gets pressure and flow tested, and then we machine it, like finish machine it. So now you've got this big chunk of material. It's got a big flat cut on one of the sides, and then you put it in that lathe, spin it at 300 RPM, 400 RPM. I mean, you can feel it in the floor, like the whole thing's just kind of shaking a little bit.
Jeez.
But it handles
Wild.
the only thing that sucks about that machine is it doesn't have thermal comp.
Right.
So it's from, I think it's a 2018, and I don't think thermal comp was really standard back then. And I don't think anybody even thought like, hey, let's make sure it has thermal comp. Just like, oh, we get a lathe, cool. But yeah, so it doesn't
Does it
have
have a probe on it? Does it have a tool probe on it?
no. Well, it's got a tool setter.
Tool setter. Yeah.
Yeah, it's got a tool setter, which is really nice.
I wonder if you could cheat with macros and cheat some thermal comp into it.
Well, the problem is, so you're holding like, I don't know. Maybe it would work. I should try it and see how much difference there is once the machine's warmed up. See how much it changes, because it really depends on what's growing. And I think I don't really know exactly where it's growing, which axis or.
Well, it's just X and Z, right? It's just two X's. Yeah, it's just,
I was thinking of like you have the spindle, and then off to the side you have the mount for the tool setter. So if the tool setter is mounted to part of the casting way over here that's lower,
I see what you're saying,
and everything's growing up and out, the tool setter may not be moving, but the spindle and the tool, your turret are.
I understand what you're saying,
and they're moving,
right,
both up. So, anyways,
right. That makes
but
sense.
whenever you're trying to hold like an 18.5-inch fit plus one minus nothing, it's
Wild.
you need thermal
Wow.
comp. So we usually end up offsetting. We'll do like 20 thousandths per side in X, and then 5 thousandths on the faces in Z for our finish pass. And so what we'll do is offset our tools up and out, or if it's a boring bar, down and out, and run the whole part, inspect it as best we can in the machine. Which sometimes we aren't. It's difficult trying to measure with 18-inch calipers or 20-inch calipers. Kind of sucks, but mics.
I
Although
was about
sometimes
to say,
we've done it with. We've got a set of 24-inch Mitutoyo digital calipers, and we've gotten pretty close with that quite a few times. But anyways, so trying to measure all that, then you make your offsets, run it, hope it works out, then and go inspect it on the CMM or put it in a mill. So maybe it's got a mill operation after, and check it with the probe on the mill. But anyways, no thermal comp on that is kind of the downside to it. Granted, it's standard now. If we were to buy that lathe today, it would have it.
I wonder if it's just a software option. Like, I wonder if DN could come out. They've asked and they said no.
I've asked it. It's hardware and software. So, and I don't remember.
The DIY like problem solver me was like, we can get a thermocouple and a Raspberry Pi, and we can
I mean,
this shit out.
Yeah, I would think you would need to install thermocouples into the casting,
right?
And then I don't think it has. I don't even know if it's got it in the ladder. I want to say I was asking the guy about it when he was at the shop, and he was like, "It's not even in the ladder. Like, it's not there at all."
Right.
And so you'd have to figure out how to add that.
But the thing ultimately, what you could do is I mean, again, this is probably more work than
it's a thermal expansion based on what your features are. Honestly, that's not a bad idea. I would like to try that and see how it correlates, and just watch it and continue doing things the way we're doing, but compare it to what our temperatures are at the time from when we started.
Yeah. And so another thing you could do is, like, depending on like what inputs and outputs it is, if it has some inputs open that you could use and look at, it could be like, honestly, if you had 4 probably wouldn't be enough, but if you had like 6 inputs, or 8 would be perfect, because then you have 256, gray bit. You could do like gray bit logic with relays and Arduino, and like look at a thermocouple, and then you have a sub program you call at the beginning of the program that then is looking at which inputs are active and mapping that to where in the thermal growth map you are, and then adjusting the global shifts when that happens. It's not worth it. Don't do it. Like, it's not worth the time, but it's fun to think about sometimes.
Right. Yeah, that's the kind of stuff where I'm like, I would love to come here every day and just not actually work and do all this stuff instead.
Why do you think I have a machine shop?
Right.
It's not to make parts. It's to do the fun problem solving stuff.
Yeah. Maybe I'll retire and then hire myself back on as
a consultant.
Give it like 3 weeks. He's gonna mail you a kit, Cam. With instructions.
Yeah.
Here's the thing, Jarrett. In all seriousness, have you ever considered like becoming sort of like a consultant for things like this? Because you've already given me a lot of help with this job. You've given Cam some ideas here. You've helped other people. I mean, because of the whole issue of most of your machinists either don't know a lot of this stuff, like everything you just said went way over my head. And so, and they don't have the time, they don't have the knowledge, they don't have the resources. You come in and do something off the wall like that.
Well, so those people exist, right? Like, my answer to that is like, call Chris Sabatini, right? Like, that's fair. That's the answer, right? Like, the answer to this is call Chris Sabatini and spend money. Like,
if
that's
you go
the answer.
In depth as you are, would he go in depth with that stuff?
Well, but the thing is, like, you shouldn't do it, right? You like, if you're really fighting thermal comp that bad and you need it and you can't work around it, then you buy a machine that's thermal comp. Like, in a world in which your goal is to make money, like, spending time chasing down weird rabbit holes is not necessarily the best use of your time and money. If you have more time than money, or if you enjoy doing it like I do, then like maybe that's the right way to go. If you're a one-man shop and you want to build a robot integration, like, we talk about the robot right now because it's a successful thing for me, right? I've implemented it. It's working for me. It's making parts. It's really cool. Like, it genuinely is. Robots are cool. But like, I also have a box in my garage that's labeled Ghosts of Projects Past. Because there are a lot of things that I started and was like, this would be a really fun thing, and I'm going to figure this out. It's going to solve this problem. Blah, 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 blah. And it didn't. Right? Like, it just, like, either like I got far enough into it, like, oh, I understand how this thing works now. I don't need to know more about it because this actually isn't going to solve my problem. Or I get far enough into the rabbit hole that I go, oh, there's a reason these things cost so much money.
Yeah.
Maybe I can't build one by myself or shouldn't build one by myself. And if you look at that, that's I built my own CNC machine. I converted a manual to a CNC machine, and I don't own that machine anymore. I own 2 industrial machines that were built by companies who specialize in making CNC machines, right? Like, if the solution was always like bootstrap it, I would still have that machine, but I don't, right?
Mhm.
To answer your original question, Pat, I've thought about it. It's fun. That's the thing I have the most fun with. I don't have time.
Yeah.
And, I already travel enough for the movie job that I don't think my wife would enjoy it if my side job was also traveling to people's shops.
Right.
That being said, I still want to help people. Like, I'm still down to help people do stuff. I'm still down to talk robots. If someone wants to talk robots, hit me up on Instagram. Like, I'll chat robots all day, or chat macros and things like that. And I think, and it's also a thing, like, you can only learn how to, like, you said it went over your head. It didn't go over your head because you're not smart. Like, it didn't get over your head because, like, you haven't done any research on it. Like, you haven't done like the weird deep dive into like weird obscure YouTube that I have on that particular topic because one night I was up late and wanted to learn about that particular topic, right? Like, we only know the things that we know because we know them, and the only way to know more things is to decide we want to know them, right? And to look them up and to do them. And the way to get good at macros is to start bad at macros and then get better, right? The only way to the way to get, I don't know. It's the same way we all got good at CNC machining, right? We weren't born naturally machinists. We like started bad, and some of us have gotten better.
Mm-hmm.
Yeah.
It's a
I
good
think
way
a
to
lot of
put it.
people forget about the machining adjacent subjects.
Yeah.
Like macros and, robots and all that stuff. If it's not necessary, then what's the point of learning it? I think is the way a lot of people look at it.
Right.
I've never
And
had a
it's
problem. You don't come up with a solution.
You're
right.
Yeah.
And it's the same thing of like, if all you have is a hammer, everything's a nail, right? And so in my world, I want to have a lot of hammers, a
Yeah.
lot of different type of hammers, so that like if I see a problem, I'm gonna go, okay, I know I can 3D print that. I know I can machine that. I also know that like I can call this buddy who has a sheet metal shop and I can do that. I can do whatever this thing is, I can solve the problem.
Yeah.
But it doesn't necessarily have to be in this particular niche that I'm in.
Yeah.
Um,
Part of why you're able to, or part of why you know so much about so many different things too, is you've got your own company. Well, your own hobby that's gotten out of hand.
yeah.
And you have the freedom of movement, so you can go any direction you want to with it.
Right.
Whereas when you work at a company as an employee, you don't really have that. Or you might try to implement some stuff like, hey, I could use macros to make this process better, and then somebody shuts it down and like, no,
Yep.
no, what we're doing now works. Don't change it.
Mhm.
So
I mean,
Good
same route I'm going in with this probe. I've had it. I've never really had a use for it, but now I do. Now I have to figure it out. Now I have to deep dive into it and learn how to use it.
right.
Yeah.
And-
And you'll be better for it.
Yep.
Like we all are, like, even if you, I don't know, it's an interesting thing because I also have the advantage of like, I know a lot of guys with one-man shops. That shop is what's supporting them and their family.
Yeah.
Right. Like, I am very lucky that we talk about this being a hobby out of control, but part of that is I have a full-time job that I do outside of this. And the film industry job is, I like the way it's structured in that, like, I'll go work for 8 weeks and work 75-hour weeks, and then I'll have 5 weeks off. Right. And so in those 5 weeks, I come to the shop, I can mess around, I can make parts, I can, and like selling things is a sort of a means to an end, in the idea that like, if I didn't sell things, I would be making a lot of things for no one, and it's too expensive of a hobby to justify having 2 machines and a robot if I'm not making parts. And I also do genuinely enjoy making parts, right? But I'm also able to go down rabbit holes and go down things and spend 3 weeks setting up a robot, integrating a robot, and not really making very much money in those 3 weeks because I don't have to, if that makes sense. And that's a very privileged position. And that's a very, like, I recognize the fact that that's not a position many people can go to. So, and to build on that, I think the idea that sort of started with me doing that CNC machine and now being comfortable with machines to repair them and being comfortable to deep dive and like learn about Fanic ladder and installing a 4th axis in a probe and understanding the Haas control enough that like I, at one point the Haas, like the board died when I first got it, like a month in, and I had to replace the board on it. And I reloaded all the software. I reinstalled the board. I did all those sort of things. And like part of that's because like I'm a little bit cheap, and it's cheaper for me to do it myself than pay some random Haas technician that I don't even know if he understands what's going on or not. to do it. But the flip side of it too is that like the more you know, the more comfortable you are doing more things. And the more comfortable you are doing more things, the more you learn, and therefore the more you know. There is something to be said about being willing to learn a little bit of stuff. And like, yes, technically it's not needed, right? Technically you can be a machinist, you can make good parts without having all these like adjacent skills. I think in general, the more we understand how the tools work, and this is like something that comes back to the film industry as well. If I understand how the filmmaking tools work, I can better apply those tools to the problems at hand.
Yeah.
Right.
I just like to know how stuff works. I mean, I was the same way as you growing up. I was taking everything apart. I've always done all of my own work on pretty much everything I've ever owned. But so even like whenever it comes to, a CNC machine, I want to understand like, how does this table even move around? How does that work? What makes it move? What tells that thing to actually turn to make this thing move? I want to understand the theory of operation behind everything. That way, whenever there is an issue that comes up, I can at least have somewhat of an idea what direction we need to go. Who do I need to call? Or is this something that could be simple? What might the problem be?
And the one sort of downside to that like level of, knowledge and or understanding the machines is there are times in which you go, yeah, it's probably not a problem. I'll just live with it. It'll be fine. Like at one point my dad had a truck that had like in fourth gear, the automatic transmission was slipping slightly, like, or sorry, in fifth gear, slipping slightly, like overdrive, going up hills. My mom was like, "Oh, you should just get the transmission rebuilt, like, or get a new transmission. Like, it's not safe to drive all this sort of stuff." I was like, just look into fourth, going up hills, you're fine. Like, there's nothing like even if fifth gear goes out completely, it's still drivable. It's not going to strand you,
Right.
And so there is a little bit of that thing of just like, yeah, that like, rotary error that happens on the Haas every time I boot it up. That's like a checksum error. It's like that's not a problem. Just clear it and go on with your day.
Well,
But,
the
who
gray
cares?
area, the gray area is much more narrow.
Yes.
You
Yes.
understand how far you can kind of push things or what you can let slide. That happens with me and my wife all the time. There will be something happening. I'm like, that's good. Yeah, just roll with it. It'll be fine. She's like, are you sure it's gonna be fine? Yeah, it's fine. Okay.
Yeah, it's fine.
Let's see.
So
Yeah.
I don't know. It's interesting. I mean, the only reason I'm here on this podcast is because YouTube exists, right? Like that's how I got into this in the first place, and how I learned everything was just the internet.
Speaking of YouTube,
Yes,
when are you gonna start doing some robot videos on YouTube?
I know I should do that. Well, if people actually want to see a video about the robot and how it's set up, comment down below on YouTube or wherever this thing ends up being on,
Everywhere.
and let me know because I want to, but also I feel a bit imposter syndrome that like I don't have the authority to like be the
Hey.
person who says that because
You're-
I
you're
don't know what I'm doing.
Your robot- yeah, your robot's working way better than my robot.
Well,
I know
that's
nothing.
fair.
There's a lot of people out there who are kind of bootstrapping everything. Even at jobs, like it's an employee. They're like, hey, I need you to just figure this out. And so like, all right, cool. We'll just make it happen. Figure out how to get a robot on this thing. And so you going through it and saying like, hey, here's what I figured out. Even garage shops, like,
Right.
here's how I did it. Here's how I implemented it all. This is a way that you can just do this at home. This isn't some giant FANUC robot cell
Right.
that needs a whole bunch of integration and is just kind of unachievable on your own.
There's probably a lot of people in your same situation that want
Yeah.
to do it, but they don't know how.
Yeah.
Right. And that's fair. That's fair. I should do it. Okay. All right.
Yep.
You've convinced me.
Good.
I'll do
Do
it.
On that note, I feel like we brought everything kind of full circle, so might be a good time to wrap up, eh? So, Jarrett, thank you for joining us, man. It's been a pleasure.
Thank you, Mr. I like I said, this is a hobby, so this is fun for me. I'll talk about this stuff all day. So
Absolutely.
I appreciate y'all bringing me on, and also all the guidance that y'all have given me after the past few years in the chat. So
That's all for this episode of the Impractical Machinist podcast. If you enjoyed this episode, be sure to hold on. That's all for this episode of the Impractical Machinist podcast. If you enjoyed this episode, be sure to subscribe on Spotify, Apple Podcasts, or the Practical Machinist YouTube channel so you never miss an episode.
Thank you for listening. If you liked it, give us a 5-star rating, like the video, like the podcast wherever you are. If you learned something from us or disagree with us or you want to teach us something, then go ahead and leave a comment. We'll be happy to hear it.
If you have any follow-up questions, you can message us on Instagram, the Practical Machinist Forum, or on the Discord in our Instagram bios. Check out our Instagram. Pat is at JobShopperTN. Cam is Machining is Cool, and I'm at Marvel Machining. And you can find Jarrett at Possum Solutions.
Thanks for listening, and we'll see you next time. Keep those chips flying.